So today let's start with this problem. The question says, given a digit n and an integer number sum, print all the n digit numbers with their digit sum equal to the given sum. Okay, fine. Let me tell you in clear words. As you can see here, the input is 2 and 6. This means we have to print all the two digits number whose digit gives me a sum of 6. For example, you can see 15, 5 plus 1 gives me 6, okay? Then 24, 4 plus 2 gives me 6, okay? Similarly, we have to print all the two digit numbers. Fine. I am giving you a question. Do one thing, don't print two digit number. Print a single digit number which gives us a sum of 6, okay? Now, how would you do that? So, I would frame a recursive equation, okay, not a recursive equation, I would frame a recursive function which would have these two parameters. So the two parameters, one parameter represents sum and the other parameter represents the number. So the sum is basically nothing but the sum of the digits, okay, you will understand it. Now my job is to print all the one digit number that has a sum of 6. So what I would do, I would have 9 options. Why 9 options? Because there are 9 digits which I can choose from 0 to 9, isn't it? So I have extended 9 branches here. Fine. What after extending these branches, what happens? You can see here that in this case, when I had the digit 0, when I took the digit 0, my number turned to 0. And since I have a single digit, so the sum of the digit is 0 only. Similarly, for 1, I have my number has now turned from null to 1. Initially, I had no number with me, so it has a null string. I am taking it as a string, okay? Similarly, here, when I took 2, it became 2 and the sum is 2. And this goes on. Now, when I reach this node, which is 6, this branch, now I take the digit 6, thus my number becomes 6, and I see one thing, that this thing you can see here, this is the sum and this is equal to 6, and that is my question. That was my question, sorry, where my question was. I told you to print all the one digit number. Don't look at this 2. What I told you was print the one digit number that would have a sum 6. So in this case, my answer would have been this 6 itself, okay? This 6 would have been my answer, and there is no other one digit number which would give me a sum of 6. Now by the first level of this tree, which we can see, we have generated all the one digit numbers possible. Now, as given in this question, we need to generate all the two digit numbers, okay? That gives a sum of 6. Fine. Now, understand one thing, what we are going to do now. Assume what happens in this case, you can see, okay, assume this, okay? Here my number is 3, okay? You can see my number is 3. Okay, fine. I am having a digit 3. Now, I need to make all the two digits number that has 3 at the unit as the, sorry, not the unit digit, as the 10th digit, okay? This means I can add 30. This will give me a 30, 31, 31, 32, 33, 34, and like this, okay? It will go on till 39, isn't it? So I would do the same thing here, what I have done here. I would extend again 9 branches from here, 1, 2, 3, and each branches will have 0, 1, and 2 representing the unit digit value, okay? 3 I am already having this 3. I would include 0, 1, 2, and like this, okay? Fine. Let's understand this by few examples, okay? Okay. Now, we would be, since it is a recursive solution, we would be going level by level, and we would start recursive calls from this node now, okay, from 0, 0. This is the sum, this is the number which I am having now. Fine. So what would happen now? I would extend 9 branches, as I told you. Each branch would have values from 0 to 9. Now, due to these digits which we have taken into consideration, now our number would look something like this. you can see here. Okay, fine. These are the numbers which we constituted. Since I have taken the digit 0, so previously my number was 0 and 0 is concatenated with this. I am taking a string. Okay, remember this always. This 0, this branch 0 is concatenated. Again 1 is concatenated to 0. The number becomes 0 1. This 2 is concatenated to 0. So the number becomes 0 2. Similarly, all the things happens. Now, an interesting thing I would like you to observe that in this branch, when I take 6 as a digit, I find that the sum turns to 6. Remember, our question says that we need a 2-digit number which gives us a sum of 6. Now, this level gives us a 1-digit number. Okay, this level would give us a 2-digit number. Now, we will not extend again 9 branches from here. Okay, because if I do this, then I would get a 3-digit number. Finally, what I would do now, that when I got a sum of 6 here now. Okay, fine. Now I have an option to print this, because this is a candidate for my answer, because this has a sum of 6. But before adding it to my answer, since I am at level 2, I am sure that it is a 2-digit number. I would do a very small thing here. Okay, since I have taken the numbers as a string, you can see I have taken the number as a string, and the number here you can see it is 0. It is 06, isn't it? So now I would return this 06. Okay, not I would return, I would check whether this 06 which I am having as a string, is it having a 0 in its starting character. That is, whether the starting of the string has a character which is 0. Okay, if it is so, then this is not my answer. This could not be my answer. If, else what I would do, I would take it as my answer. Okay, once all the operation for this node is over, my control comes back to this node. Okay, now in the similar manner I would be extending the 9 branches from here also. Okay, why I would do that? Not only from here, from here, from here, from here, from all the rest of the branches. Okay, why I would do that is, here in this case you would see that if I when I extend the 9 branches, my number is initially 1. Okay, you can see 1. After extending the 9 branches, I would get the numbers from 10 to 19. Okay, here the number is 2. I would, after extending the 9 branches, I would reach the numbers 20 to 29. Similarly here, I would reach the numbers from 30 to 39, and this goes on until 99. Okay, so what would happen now is, from 1 we would extend 9 branches, as you can see here, in a similar fashion. Now these 9 branches would represent the 9 digit, as we have seen before also. Now what would happen? We would start framing the numbers. Okay, let's frame the numbers. What happens here? You can see here the sum was 1 and the number is 1. Okay, now I have added a 0 to the sum. The sum remains same and the number becomes 1 concatenated with 0 is 10. Fine. Similarly, this will go on. Here what happens? The sum was 1. This is a 2. Okay, don't get, this is not 1. The sum was 1. 1 is added, it becomes 2. Sum becomes 2 and the number becomes 1 concatenated with the already present 1 is 11. Here what happens? The digit is 2. The sum was 1. 1 plus 2, the sum becomes 3 and the digit becomes 12. 1 and 2. Now at this node, similarly this continues, and when we reach this node here, I see that the previously the sum was 1. I added a digit 5. Okay, now 1 plus 5 gives me a sum of 6. Okay, and this is the sum which I need. Again I see what is the number framed. 1, it was initially 1. I concatenated a 5 with it, I got 15. Now again I would check whether this 15 is having a trailing 0. Is it? No. In the first character it does not have any trailing zeros. It is 1. So this is an answer. Okay, this is a potential candidate for my answer, and you can see in the question also. Sorry, where is the output for this? Yeah, you can see this 15 is an answer here also. Okay, So I got my first answer here. Similarly, what would happen? I would extend this as usual. All these numbers will be framed, and at last I would be getting this number. That is, sum was 1. I included the digit 9. 9 plus 1 gives me a sum of 10, and 1 and 9 frames the number 19. So at last I framed all the numbers starting with 1 and which are of 2 digits, so 10 till 19. And similarly for all these nodes, this will be framed till number 99, because 9 would extend the branch to 90, 91, 92, 93, and it would check whether wherever the sum is 6 6, it would take and print that, and also check whether it has a trailing 0 or not. Okay, so this is the recursive way of thinking this problem.